Hello everyone, I am Aditya Sauri. Today our topic is binary search tree. A binary search tree is a binary tree. It may be empty. If it is not empty, then it satisfies the following properties. Every element has a key and no two elements have the same key. The key in the left subtree are smaller than the key in the root. The keys in the right subtree are larger than the key in the root. The left and right subtrees are also binary subtrees. So here binary search tree is a binary tree. So we already know what is binary tree and how we can construct it. But for binary search tree we have two rules, basic rules, that is all the elements of left subtree must be less than root and all the elements of right subtree must be greater than root. So these things will follow for subtrees also. Here we can see an example of a binary subtree. Now let us see how it is constructed. So now we are taking same elements. So 16, 12, 20, so here the starting element is 16 and here we don't have any tree. So the basic rule is if the tree is empty, the starting element will become a root. After that, left side elements must be less than root element and the right side elements must be greater than root element. Now another element is there, that is 12, so it is less than 16, that's why we have to place it left side, and 20 is greater than 16, so that's why we have to place it right side. After that we have another element, that is 11, so 11 is less than 16. After that we have another element, that is 12, so here 12 is the largest element when compared to 11, so we have to give this thing left side. After that we have 14, so 14 is also less than 16. After that 12, here 14 is greater than 12, so we have to place it right side. So same rules we have to follow. After that we have 19, it is less than 20, so we have to place it right side. After that we have another element, last element, that is 13, so 13 is when compared to root node it is less than less element. After that 13, so it is greater than 12, after that 12 value, so 13 is greater than 12, so we have to send it to right side. In right side we have already one element, that is 14, when compared to 14, 13 is less than 14, so we have to place it left side. So in this way we can represent binary search tree. And in binary search tree we have few operations, that is insertion, deletion, searching, minimum element and maximum element. So now let us see each and every operation by using an examples. Now let us discuss how to construct a binary tree by using elements and how to insert new elements in binary tree. So we have three properties to construct and inserting elements. If the tree is empty, then consider the elements as root elements. If the element is greater than root, the insert to the right subtree. If the element is less than the root, then insert to the left subtree. So these are the basic rules to follow to construct a tree and to insert new elements. Now let us take a small example. So here I took 8 elements: 44, 37, 21, 55, 67, 78, 10, 89. Now let us see how to construct a binary tree. So here we don't have any tree, so we have to take the first element as a root element. So here 44 become a root element, and another element is 37. Now we have to compare with root element. So compare it to root element, 37 is the smallest element. So we have to insert this element to the left side. After that we have another element, that is 21. So 21 is also smaller than root element. After that we have 37. Now we have to compare it with 37. So 21 is smallest element, so we have to place it left side of 37. Now we have another element, that is 55. So compare it to root element, 55 is greater than root, so we have to place it right side. Now we have another, that is 67. So 67 we have to place on the right side because it is greater than root element and 55. After that we have another, that is 78. So compare it to these three elements, 77 is the largest, so we have to place it at right side. After that we have 10. So 10 is the smallest element, compare it to left side nodes, so we have to place it here. After that we have 89. So compare it to root node, 89 is the largest element, and we have to compare each and every element, so we have to place at right side. So in this way we can construct a binary tree using elements. Now let us see another example. Here I gave 5 elements: 50, 30, 10, 60, 80. Now let us construct a new binary search tree. So we don't have any binary tree here, so we have to consider the first element as a node, that means root element. After that we have 30. So 30, when we compare it to root node, 30 is less than 50, so we have to place it at left side. After that we have 10. So compare it to root, it is less than, and compare it to this 30, it is the smallest, so we have to place at left side. So after that we have another element, 60. So compare it to root, 60 is the largest number, so we have to place at right side. After that we have 30. After that we have 80 element. So compare it to root, 80 is the largest than 50. After that we have another element, that is 60. So compare it to 60, it is the largest element, so we have to place this 80 at right side. Okay, so now I would like to add some new elements in binary search tree. So now I would like to add 20, 55, 33 elements. So here I gave 3 elements as a new elements. Now I would like to add these elements in binary search tree. So now we have 20. So compare it to root node, 20 is small, so we have to send this 20 element to left side. So compare it to 30, also it is small, so we have to insert at left side, but we have an element in left side, that is 10. So compare it to 10, it is the largest element, so we don't have chance to insert right side and left side also, so we have to do comparison. Okay, so compare it to this 10 element, 20 is the largest one, so we have to place it right side, not left side. So compare it to 10, it is the largest element, so I have to place in right side only. Now we have another element, that is 55. So 55 compared to 50, it is the largest element. After that we have another element, that is 60. So compared to 60, it is the smallest element. So we have to place the every small element in left side only. So 55. Now we have another element, that is 33. So compared to node, root node, it is smallest element. After that we have 30. So compared to 30, it is the largest element, not the smallest. So largest element must be placed at the right side only. So in this way we can construct a binary search tree and we can add new elements in binary search tree. So in this way we can insert new elements also. Now let us discuss another operation, that deleting elements in binary search tree. In previous examples we discussed how to insert new elements, and in this topic now let us learn how to delete elements in binary search tree. So to delete the elements we have to follow some steps. Deleting a node having no children, deleting a node having one children, deleting a node having two children. So in binary search tree we already know that. So what is binary search tree? So it may have 0 children or 1 child or 2 child. So this is called binary tree. Okay, so a node having no children or 1 children or 2 children is called binary tree. So we already discussed what is binary tree in previous videos. So to delete a node we have to follow these steps. So the node which have no children or 1 children or 2 children we can delete, but we have different things to implement these types. Now let us discuss each and every point, how to delete the element. Now let us take a small example to delete. Now let us go for how to delete a node having no children. So we already discussed we have 3 types to delete an element: deleting a node having no children, deleting a node having 1 children, and deleting a node having 2 children. Now let us discuss this example regarding deleting a node having no children only. Later we can discuss these 2 things. So here I took a small example: 8, 3, 10, 1, 6, 14, 4, 7, 13. So now let us discuss our topic with the help of these elements. So to do, okay, in this topic we don't have binary search tree. Now let us just construct a binary tree with the help of these elements. So our first element is 8, so it becomes a root. After that we have 3, so compared to 8 it is small. After that we have 10, compared to 8 it is the largest one, so we have to place it here only. After that we have 1, so compared to 8 and 3 it is the smallest one. After that 6, so compared to 8 it is the smallest element, and compared to 3 it is largest element, so we have to place 6 here. After that we have 14, so compared to 8 it is the largest element, and compared to the 10 it is the largest. After that we have 4, so compared to root, that is 8, it is the smallest. After that 3 we have, so 4 is the largest element compared to 3, so we have to send it to the right side, but we have one element in right side, that is 6. So compared to 6, 4 is the small, so we have to place to left side. After that we have 7, so compared to 6 it is the largest element, so we have to place it the right side. After that we have 13, so compared to 8 it is the largest one, Compared to 10, it is the largest one. Compared to the 14, it is the smallest element. So we have to place at left side. Now we have to delete the nodes having no children. So in this example, this 1 and 13 don't have any children, and these things are called as leaves. So now we have to remove this 1 and 13 element. So simply I am erasing this thing. So in this way the tree will be, binary search tree will be created after deleting the nodes having no children. So in this way we can delete each and every node in which having no children. Now let us discuss how to delete a node having one children. So here I am using the previous example only, same nodes, and when we see here, already I draw binary search tree using those elements only. Now let us discuss how to delete a node having only one children. So in this example, every node has two children. For 8 it has two children, for 3 it has two children, for 6 it has two children, but here for 10 it have only one children, and for 14 it has only one children. So here we have to delete the node having one children, that is 10 and 14. So first we have to come by order. So first 14 and 10. So we have to delete these two elements because these two elements only having only one children. Now let us discuss how to delete. So when we are coming by order, first we have to delete the 14 element only. While deleting a node having one child, here the child will replace the position of parent. So if we delete leaf nodes, there is no problem because the leaf node will be the last element, no need to change the positions also. But while deleting the node having one children, we may change the element, because here if we delete the 14, here 13 will become as here 13 position will be changed. So after 10 we have 14. If we delete the 14, 13 will replace here. So as per construction of binary tree, 13 is the largest element compared to 10, and we don't have 14 element. So that's why we have to replace the 13 element in 14th place. So like that we have to change the positions. So now let us see. First I am deleting the 14th element, not the 10, only 14th element. So 8, we already know how to construct. So directly I am placing the steps. 6, 4, 7. So now here we are deleting the 14 element and we have only 13. So compare it to root node, 13 is the largest element of root. After that we have 10. So compare it to 10, 13 is the largest. So we have to place it here, and we don't have any 14. So that's why here 13th position is replaced from here to here. Now we have to delete the another element, that is 10. So again 10. Again I'm drawing the same. So first we have 8, 3, 1, 6, 4, 7, and previous step I deleted only 14 and now I am deleting 10. So we have only 13 value. So compare it to root node, 13 is the largest one. So we have to place it here. So this is the final output of the binary tree. So in this way we have to delete step by step. Of course I said as stepwise, but there is no need. We can delete 14 element first or 10 element first. No need to follow the rule. So depends upon the steps only, it will be implemented like this. Now let us discuss how to delete a node having 2 children. So we already discussed deleting a node having no children, deleting a node having 1 children. Now let us discuss deleting a node having 2 children. But in this, while deleting 2 children, we may get different results while constructing a tree after deleting 2 children. So now let us see how it will works. So when we compare it, goes to the example, here 8 have 2 children, 3 have 2 children, and 6 have 2 children, and remaining are containing only 1 children or leaf nodes. Okay, so 8, 3, 6. Here we have to replace parent with child. And for example, if I like to delete the 6th element, for 6th element we have 2 children, one is 4 and one is 7. So we can replace the child as a parent. Maybe it is 4 or 7. So we have to replace only one child here. So this is the main condition while deleting 2 children. Okay. For example, if we like to delete the 6th element, we have to replace the child as a parent. But for 6 we have 2 children, that is 4 and 7. So we can, okay. So we can replace the 4 as a parent or 7 as a parent. As per our requirement, as per our wish, we can implement. So that's why I'm saying maybe we can get different types of binary tree after completion. So for example, we have 3 here. So if we like to delete the 3, for 3 we have 2 children, one is 1 and 6. So we had to replace this child as a parent, maybe 1 or 6, but not 2. We have to replace only one child node, either it's left side or right side, but not 2. So that's why I'm saying output may get in different variations. Okay, now let us see a small thing. Now I would like to delete the 6th element. Okay, 8. So we already know how to construct this thing. So now I am not explaining here. 14 and 13. Now I would like to delete this 6. So after deleting the 6th element, what we have to do? Either we have to replace the left node as a parent or right node as a parent. Now I would like to replace a left child as a parent, that means 4, and we already know 7 is the greater compared to 4. So in this way we get the output. If we like to replace the right node as a parent, that means 7, and compare it to 4, 7 is the largest compared to 4, so we have to replace here. So in this way we can get the output in two ways. Okay, now I would like to delete the 3. So again I am writing 7, 4, 10, 40, 13. So now I would like to delete the 3. For 3 we have 2 children, left side is 1, right side is 7. So we can replace any one of these 2 children as a parent. Okay, now I would like to delete the 3 here. Okay, now I would like to place 7 here. So I would like to place 7, that means right side. Of course we can place 1 also, depends upon your decision. Okay, so compare it to 8, 7 is the small, so that's why it place it at left side. Compare it to 7, 1 is the small, so we have to replace this one to the left side, and we have another element 4. So now I would like to delete all these things. Okay, now we have 4 element, 4th element. So compare it to 7, it is the smallest, so we have to place at the left side, but we have 1, so compare it to 1, 4 is the largest element, so we have to place at the right side. So in this way we can get the output. If we place 1 instead of 7, we may get another output, we may get another tree structure. Now I would like to delete 8. So for 8 we have 2 children, one is 7, one is 10. Of course here also we can replace as a parent, maybe it's 7, maybe 10, depends upon your decision. Now I am using here. Okay, here only I am drawing. So 8, 7. Okay, sorry. Now I would like to change 10 as a parent. So I am replacing only the 10 element, not the 7. So now 10 will become the parent. Compare it to 14 and 7, 1, 4. So in this way we can get the output. If we like to replace 7 as a parent, we may get another tree structure. So in this way we can delete the elements having 2 children. I hope you understand how to delete each and every node in different concepts.